Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with LearnBay.co. Happy learning!
Okay, just we can see run through these slides. Next, actually, we can see look at the this virtual machine, how to use this virtual machine. Okay. So, what is Apache Spark? An in-memory cluster computing platform. Okay, I already said in-memory cluster computing. In the sense, yeah, everything it will keep it on memory. So, if you are using Hadoop for each core, okay, in resource in slave machines, okay, you are using 8 core and 16 GB RAM. Example, okay, 8 cores and 16 GB RAM. In that case, if you are using Spark, it requires more memory. Okay, so some hardware, if you are using Spark, though it is working fast, okay, you have to invest something for the hardware thing. Okay, I mean hardware infrastructure you have to invest. So the 2 GB RAM may not be sufficient to run Spark, so that you have to use at least 4 GB. So you have to upgrade. You are already using Hadoop with some kind of infrastructure, but you are thinking that I'm going to use Spark and all. You have to upgrade your hardware. It is not horizontal scaling, it will be vertical scaling. Okay, you have to add additional RAM. Otherwise, straight away you are setting up right from the beginning while setting up itself. I'm not going to use Mapreduce. I'm using Spark in the sense. Okay, based on your requirements, so you have to specify like that. For one core, I require 4 GB RAM. That is the industry best practices actually they are using. When we were working on Hadoop, okay, 1:2, 1 core equal to 2 GB RAM. So like that way only we are setting up the infrastructure. Now it's like 1:8. Okay, in some scenario, the people having hike, they are not bothering about money and all. They are 1:8 actually they are having. So if it is like a 8 core in the sense, 64 GB RAM they are having the slave machines. Okay, so memory it requires more memory. So it's like a in-memory cluster computing runs lightning fast. Okay, because it's an in-memory. It's an extension of popular framework Mapreduce. We can say that it's an extension or it's like alternative. We can say, okay, the process engine instead of just map and reduce, okay, defines a large set of operations, transformation and action. This is one biggest advantage. In Mapreduce, we already said it's like a map and reduce only. Map task, reduce task. I said, whatever the query you go, you create key value map, key value pairs, and do aggregation with reduce. Okay, but in Spark, it is not only 2 tasks are available. There are 2 set of tasks are there. One is transformation and other is actions. Okay, under transformation, okay, many functionalities are there. I can show. Yeah, see under transformation, see map task is there, flat map, filter, map partition. Okay, these many transformation tasks are there. These are all the actions. Count, see reduce is there. Okay, see here map and reduce is there. Apart from this map reduce, okay, so many transformation functions and so many actions functions are there. This is the biggest advantage. Okay, instead of going with one single tool, okay, I mean like a one set of tasks, we are going with multiple tasks, so that it will provide a lot of flexibility to work. And it's an unified stack. Okay, unified stack in the sense, because in the same tool we are having multiple modules: Spark SQL, Spark Streaming, GraphX, MLlib. Okay, everything we are having in the single software. Okay, and other advantage is runs on Windows as well as Unix system. Okay, so you can install Spark on Windows. Okay, but it won't, in Windows there won't be any HDFS file. Okay, if there are files on Windows system, you can straight away you can execute it with this Spark. Okay, that actually just you know the information, just run on Windows, because if you get into that one, it requires a lot of it will be like a proper Spark course and all. Okay, just understand that Spark you can install on Windows. That's it, and also Unix system. Okay, right. So whatever I have spoken, that's what why we are using Spark. Yeah, run faster analytics of large data. Okay, I said the reason, this particular example. Okay, So, and as it's a unified stack, okay, all components are available. Okay, it's like one of the most powerful feature of Spark is you can easily integrate with Hadoop cluster as well as Cassandra. So if you are using Hadoop or else Cassandra or any other tool, we can easily implement it. Okay, can build under an application that combines different models. Okay, this is actually one of the advantages. Can build under an application that combines different models. Okay, see, using Spark streaming, I said what is Spark streaming? So you are getting a streaming data. Okay, so what you're using the Spark streaming, you collect the data and you clean it. So the example for Hadoop ecosystem, I said, using Flume, you collect the data and store the raw data in HDFS. Okay, and using some other tool, maybe pick and clean and you store it. Okay, but if you use Spark, using Spark streaming, while receiving the data itself, you clean it and you store only the required data. You no need to store raw data and pick it. Okay, that much fast actually Spark streaming will work. Okay, while collect the data, see, collecting the data in the sense, maybe every 2 seconds you are setting an interval. The streaming interval is 2 seconds, or else you just make it 5 seconds. Every 5 seconds, it will pick the data from Twitter. Okay, maybe that particular topic, every 5 seconds, maybe 10,000 tweets will come. Okay, 10,000 tweets will come. Then next 5 seconds, another 10,000 tweets will come. But before picking the next 10,000 tweets, within this 5 seconds, it will process all 10,000 data and it will pick only the exact information and it will store it within that 5 seconds. Within that, before picking the next set, it will complete this process. It will store in the HDFS. Okay, that much fast actually Spark can work. Okay, so using the Spark streaming, when you are getting the tweet, okay, and you are storing on HDFS, the same way you can build a model for sentiment analysis or something, or some other classification or something if you want to do. Okay, same you can run at a time. Okay, what it will do, the Spark streaming will process the data. Okay, after coming out of Spark streaming, one copy will go to the HDFS and another copy will get into the model, and the model will provide the result. Okay, so what's the advantage? See here, you are having maybe later stages, you can do some combined analysis later, but with this immediate analysis, if you want to do this kind of, we can. So that's what we can build. Applications combine on different modules. Okay. You might have faced that for credit card, if you are using something and all, you will be getting some alert immediately. How it is coming? Alerts like that only. Okay, so if any other visa or something, per second hundreds of transactions are happening. Okay, per second hundreds or thousands of transactions are happening. It is picking the data, cleaning, as well as the model is cross verifying that whether it's a fraudulent transaction or not. If model is detecting that it is a fraudulent detection, you are getting it. You might know that if you are some unusual transaction, if you are doing, within 1 minute you will get a call. Okay, so those kind of the combination of models, we can use it with this Spark. Okay. This provides support from different types of data like JSON, Parquet, Hive tables, etc. Whatever the data types are there, we can process it. Okay, and interactive shell framework. That what is the shell framework? When we are looking into the Hadoop environment, I'll show what is the shell framework. Okay, Spark streaming can be easily integrated with high throughput framework like Kafka. Yeah, just before I said Kafka, it is like alternate tool to Flume. Okay, so yeah, if the Kafka is a messaging broker. Okay, the Spark cannot go straight away connect to the Twitter environment and it will pick the data. Okay, instead of it can, but you are unnecessarily providing burden to Spark. Okay, instead of that, what you do, you use an intermediate tool, a mediator tool to Kafka. Okay, this is a messaging broker. You connect the one way, from this way you connect the Kafka to this Twitter framework. Okay, and this side you connect with the Spark. Okay, then the Spark will take care only. It will pick the data from Kafka and it processes it. So it won't, we are not providing additional burden to connecting and, getting the data. This Kafka will collect the data and, it will keep it here. Spark will pick it from here. Okay, we can easily integrate it with Kafka. This is the advantages of using Spark. Yeah. So, so these two we have seen. If you have any questions, you can ask me before moving into other slide. Okay. I hope you people are fine. Right. Right. Next, actually, this is actually Spark ecosystem. Okay. The Spark core programming is there. If you want to do this is like a pure core coding and all, like a Mapreduce and all. If you want to write some raw code and all, we can use Spark core programming. And top of it, we are having multiple modules: Spark SQL, Spark MLlib, Spark streaming, Spark graphics. All four we already have seen for what purposes actually we are using it. And also one thing called Spark R is there. Okay, the Spark R is another model. This module we can use only for machine learning purpose. If some people are very good in R, okay, but your data is on Hadoop, what do you think that it's a very huge data? If I implement that code only with the Spark, then only it can process fast. No need. You have to get this information. That's it. You have to understand how Spark is working. That's it. No need to concentrate about Hadoop. Just whatever the information I'm having, so it's an additional information. Okay. Because as a data scientist, just after getting the data, what we have to do? Just look at the data, identify the pattern. Okay, and that's why we have to concentrate. But in practical, we cannot do the same thing. Am I right? If they are saying that your data is there in the Hadoop and all, if we already understand, then we can design our module like that. Okay. This Spark R. Okay. Then there is a module called Spark R. Okay. What do? You write the code on R. Okay, and implement on Spark. Okay. Then Spark will execute it. Okay. Right. So the Spark can here HDFS can be there, Cassandra can be there, any data, like a file system can be there. Anyway, the Yarn, resource management, am I right? Multiple resource tool you can use it. So the Yarn is the one of the best tool. Okay, and also Apache Mesos is there. It is alternate to Yarn. Okay, so any other tools, if you want to, I don't want to use this resourcing tool and all. I'm having Spark on only one single system. They're like, you are developing small prototype or you are testing something and all. If it is a only single system you are having, you just make it a standalone cluster. Okay, you don't need to use resource manager and other thing and all, resource manager, node manager and all. Just using one single machine, in same machine only everything will be running. Okay, you can execute it. This is actually Spark ecosystem.
Yeah, excuse me.
Yeah.
What are all these Spark SQL, Spark R, all those above? What are those?
In the module, just before I said, the Spark streaming is to collect the streaming data. Okay, Spark SQL is if you want to process structured data using data frame. Okay, you can process it. And Spark MLlib, it's like a machine learning. This graphics is when you are working on like edges and nodes, like a LinkedIn. Connection, multiple connections, same like Facebook. If you want one friend is there, okay, from friend connection and friend of friend. Okay, if you want to do those kind of analysis, okay, we can use this Spark graphics. Okay, based on this only, actually, you are getting friend recommendation in this one Spark. Sorry, Facebook. Friend recommendation you are in Facebook, or else in LinkedIn you are getting connection recommendation. Am I right? So those kind of thing we can use it with Spark graphics. Spark R, okay, you write the code on R, implement on top of Spark. That's it.
Okay.
Yeah.
Sir, actually in the interview point of view, they will ask the programming related to it, or they will ask the internal concepts such as the structure and all, architecture and all. They will
No, if you are going as a Spark developer, you have to face technical interview. Okay, all the technical and all. But as a data scientist, you just specify Spark on your CV. Okay, knowledge about Spark and all. There actually you can specify only concepts. You don't need to mention the technical questions and all there. Yeah, I have information about Spark, how it is working, and all those information. That is more than enough.
Yeah, thank you.
Yeah. And another advantage of Spark is a polyglot. Okay, polyglot it's like a programming languages. So polyglot in the sense in the tool you can write a program with different languages. You can write programs with different languages. Okay, this is. Nowadays actually these kind of polyglot framework are evaluating. Okay, so more whenever they are developing a new tool, it is providing. See, for example, I said Mapreduce, when they developed Mapreduce only with Java. Okay, but they said no, it's like a Java. If you know Java, then only you can write what is that, you can work on Mapreduce. Okay, the Spark is actually developed from Scala. Okay, Scala is the native language of Spark. Okay, the Scala is developed from Java. Okay, the Scala is a language. Okay, they developed on top of Java only. Okay, now, yeah, Scala. If you know Java, it is very easy to learn Scala in no time. You can learn Scala in no time. Okay, even if you don't know Java, also you can learn Scala easily. How you learn Python? Okay, even most of the people might have not known Python before getting into the data science, but now you have some, you are familiar with Python. Okay, same way we can learn Scala also. The Spark actually developed with the Scala only. Okay, and also it is like the native language is Scala. So does it mean that if you know only Scala, then only I can Spark? No. Okay, if you know Python, you can work Python, not even learning Scala. Okay. And if somebody is saying that, yeah, I'm already a Java resource, okay, I'm experienced at 10 years, more than 10 years. Yeah, Scala is good, but I'm comfortable with Java. No problem. You can write the entire thing with Java. Okay, and this R actually for machine learning purpose, actually we can we use R programming. But this Python and Scala or Java, you can develop a complete application with 3 languages. Okay. If somebody don't know Java and Scala, not even writing a single line of code in Scala and Java, with entire Python, you can develop a Spark application. That is the advantage actually the Spark is providing. Okay, so which module you are going, that way only. For example, if you just go here, Spark documentation. Okay. Maybe I'm just going the 2.3, whatever the latest documentation, just go for Spark documentation. And see programming guide. For example, I'm just looking at Spark streaming. Okay, Spark streaming. There are examples will be there. A quick example. See here, for all examples, we'll be having Scala, Java, Python. Okay, it's up to you. Okay, if you through Scala module, okay, if you execute this code, or through Java console, you execute this code, or Python console, you execute this code. Okay, everything will give the same result only. Okay, if you look at in the Spark documentation, any programming, okay, any example, everything you will be having a Scala, Java, and Python. Only for a machine learning library, MLE. Okay, you will be having R also. Apart from Scala, Java, Python, and also you will be having R. Other than machine learning, you will be having all other 3 languages. This is the actually advantage of using Spark and all. Spark is a polyglot. Okay. Anyway, as it's a native language, and also I want to give some info about Scala. That's the reason this session actually will go with Scala only. Tomorrow we'll start Scala. Okay, and one day Scala, and Monday we'll build a few models using this Scala on top of Spark.
Which one will execute more faster and which is reliable among all the 4? Yeah,
there is no difference between all. Okay, So we should not say 4. Actually, we have to say 3 only, because in R for machine learning purpose only. Okay, but the Python, Java, Scala. Okay, see the processing wise, execution time is no different at all. If you write a Python code and it is executing on 1 second, okay, this is the same functionality if you write in Java or Scala, that will execute on 1 second only. Processing time, there won't be any difference. Okay, but while developing, actually, if you use Java, generally it will take additional time to code. Okay, because Java having its own procedures. Okay, in Python, straight away you can use implement or function name. Just you can write it. But in Java, there's some class name, function name. Okay, you have to write some additional things are there, and also you have to compile that into object. Okay, those kind of things will be there. Yeah, writing code in Java while writing, comparing with Scala and Python, maybe I don't know much time based on that, but it will take more time than this two, Scala or Python. Other than that, execution wise, no issue at
all. Which one? Please repeat the last point.
Yeah, so Scala, comparing with Scala and Python, okay, Java will take more time to writing code.
Okay.
While developing in Java, if you are thinking that if you are Java, if it is taking Java is taking 1 hour, in Scala and Python you will be completing on 40 to 45 minutes.
Okay. Even the coding is also a little bit less when compared to Python in Scala.
Little bit.
Suppose if there is a code of 10 lines of code in Python.
Yeah.
How about other languages?
Yeah. If it is a Python 10 in the sense, Scala also will be 9 to 11 only. Okay, 9 line or 11 line, like that only. But Java will come for 15 to 20 line it will come.
Okay,
Java.
fine.
Okay. That's
so,
it.
Okay. I'm just trying to understand. So when we have Spark SQL, which is used for transforming the data and everything, processing, transforming everything. So why do we need to again code something and code something?
Actually, your question is coming in the point of ETL only. Okay. No, the Spark, any Hadoop tool, maybe Mapreduce framework or the Spark, we are not using for ETL kind of thing. Okay, ETL is different. Here, actually, here the purpose is actually completely different.
Okay, so what kind of what functionality do we try to achieve using Spark?
Yeah, so see, in ETL, if there is a credit card transaction, what will you do?
Okay, we try to pull in the data and we try to apply some functionality on it, and we store it in some tables for further analysis or something. So that's what we actually do. Yeah,
the same way. Okay, the same thing using Spark streaming. You pull the data, okay, and process it. You can store in HDFS or any other tool.
Okay. Yeah. Okay.
Okay. In that way, actually, more or less the functionalities are same. Okay, but there actually you are storing on another RDBMS system, maybe Oracle or SQL Server. Okay, that have some limitation and constraints. Correct.
Yeah. Okay.
But here there is no limitation anything in the HDFS when you are storing on HDFS. Okay, per day 1 lakh 1 million transaction is coming. Okay, or it's 10 million transaction is coming. Okay, your Oracle table will be full. Okay, you have to take a backup, and you have to go with other table. Am I right?
Okay.
Okay, but here there is no backup is needed. One thing. And you said that for further analysis in the ETL system, when your data is small, it will take little time. When your data is huge, it will take a lot of time. But when you do the same analysis in Hadoop environment or with Spark or Mapreduce or anything and all, okay, whatever the data size, whether it's a small or very large, it will take the very little time only. That is the advantage actually we are using it. Okay, so while pulling and mostly for processing only, we are after storing the data. Okay, when we are using when we are doing some analysis, okay, there actually this Hadoop and Spark ecosystem having it's upper hand comparing with the traditional system, the ETL or anything. Okay. In case if you're having 1 crore data in Oracle, if you run a query, if you want to process something, okay, so to get what is the maximum sale or maximum transaction per day, and if you want to do some query, if it is like a 10 million, like a 1 crore data is there, how much time it will take?
Yeah, it will hang, like it will take several hours sometimes.
Yeah, several hours on right. But if you implement the same on Spark, it will on maybe in minutes only. Sometimes if you have enough resource and all, maybe in seconds you can get it. In seconds or in minute actually you can get it.
Okay.
Now you understand, am I right?
Yeah, got it. Okay.
Yeah. Okay.
HDFS
So yeah.
is a Hadoop file system, right?
Yeah.
Okay. Earlier you told like if you install in Windows or else Linux, it will install in any of the operating system.
Yes.
But where Windows, it will not having HDFS, right?
Yeah. Yeah. There is no HDFS. You can process with Windows files. In case if you are having some huge Windows server, if you are having some in Windows itself, in a server you are having some 20 dB capacity, some files are there. If you want to process it with the Spark, you can do it. Actually, they have provided that option, but not much people are using Spark on Windows. Just they have provided it, but largely they are using on on top of HDFS only. On top of HDFS or Cassandra or any other the file system. Not much on Windows file system.
May I know what is Cassandra?
Cassandra is another kind of distributed file system, another file system like a HDFS only, another file system, okay, another tool actually. It's a big data tool only, where actually you are going to process with structured data. Okay, that also NoSQL database only. You create a table with like a 1,000 column or 10,000 column, and you can store it, you can process it.
Which is similar to Spark, you mean to say?
Similar to HBase. It's not a processing engine. It's just it is similar to HDFS.
Okay.
Similar to HDFS. Okay. See, if somebody is using SAP tool in a bigger company like Infosys or for example, some bigger government organization where 1 lakh people are working, so they will be having entire their data in one single system. Okay, vendor information, employee information, PF information, salary, attendance, everything. But it will be like different tables, different databases, different tables. Okay, on employee number and name will be there in one table, but related information, attendance, different table will be there, different tables. Okay, but if you use this Cassandra or HBase, all the information into one single table, you can have it. This one employee, okay, one set, we'll call it as a column family. Attendance family in the sense, under the attendance family, what is the number of days present, absent, all those information. Okay, salary family in the sense, basic other thing and all. Okay, leave information. Okay, so those kind of information you can keep thousands of columns, and one single row you can keep all the information. When you those kind of situation, you can use Cassandra or else Hadoop with HBase. Anything you can use.
Okay. So by using this Cassandra, we will reduce the time and fetch the data and process very quickly. You mean to say?
Yes. That's what. See, the same SAP or anything and all. After some year, you have to take a backup only. Okay, so you will be keeping only the recent years, maybe recent 2 year, recent 5 years only. Okay, before 5 years data, just they will take a backup and keep it on separate places. Okay, but if you are using Cassandra, any big data tool, Hadoop or Cassandra, MongoDB, anything. Okay, whenever huge data is coming, you scale out your infrastructure. That's it. You add some more machine or some more slaves into your cluster. You increase your cluster. So what will happen? It is like a 10 years or 15 years, all data is readily available. If you want to do an analysis, 10 years, you can do it immediately. In SAP, if they are maintaining only 5 years of the data, if you want to analysis 10 years, then the other 5 years already they are in backup. From the backup, you bring it, doing analysis, that will take a lot of time and also a lot of cost is involved. Okay. Yeah, fine. So I'm stopping Spark here. Okay, and now we can see about that virtual machine. Okay, and tomorrow we'll look into like a Scala programming And also again, we will continue Spark tomorrow. And Monday, the final class, we will build some model using Spark. Have you people downloaded the virtual machine? What are the virtual machine I have mentioned? This one, 7 GB. If not, if try to
downloaded, but while opening it, it is showing error.
Okay, you cannot open straight away. I'll give you the instruction today. How to set up and how to install. And
hi, can you please ping once again the path of this file?
Yes.
I missed the yesterday's link. I'm sorry.
Yeah, sure. Okay. Okay. Yeah, fine.
Thank you.
Yeah. See.
Does it put it into the chat or somewhere?
Yeah, it's available in the chat. Yeah.
All right. Thank you.
Yeah. Okay. We have to see what is virtual machine and all. Okay. If you people already know virtual machine about it, not an issue. If other people, if somebody don't know, okay, if you don't know, just spend some time. Okay. For example, this is your laptop or a desktop. Okay. Yeah. Can you mute your mic?
Yeah, I'm sorry.
So it's all right. Okay, so it's like for example, see here, this is your laptop or machine or something. So inside what you are having a processor. Okay, maybe you are having a processor, microprocessor and RAM. Okay, and other whatever hard disk. Okay, storage I'll make like this. Okay, your storage you are having it. This is your machine. Okay, like so you are installed Windows and other. You are working on it. In case now if you want to do something with Linux system, okay, Linux system and some Linux software, what you have to do? You have to buy a new hardware. Okay, you buy a new system with the same set. Okay, with the same set, RAM and everything and all. What do you do? And you install. Okay, you install here. You can use it. So you'll be having 2 laptops. But instead of spending amount buying a new laptop, okay, what do you do? Inside this, you virtually create another laptop, another desktop or another laptop, or in exact meaning another machine. Virtually you create one machine. Okay, then your processor, RAM, hard disk, everything is there. From this processor, you share some part. Okay, in case if you are having 2 core, 1 core for your window, okay, 1 core for here, 1 core for here, and if you are having 4 GB RAM, okay, 2 GB RAM here, and your hard disk if you are having 1 TB, so maybe you use it instead of sharing off and all. Okay, you just go for some 500 MB or something. Okay, 500 MB, 200 MB, a small amount of. You just share. We are sharing here only, sharing the already available resources here, and virtually machine is actually it is a separate machine. There is no link between this actual Windows machine or this machine. It's a completely separate machine. Okay, but only just sharing the your hardware, and here you install Linux. Okay, you install Linux and you and Hadoop or whatever thing you use it, and we can use it here. So instead of buying a new hardware, spending some amount to the hardware, this way actually we can use it. Is it mandatory that we have to use? We have to create only one virtual machine inside? No, any number of virtual machines you can create inside. Based on how much resources you are available. Okay, so this works. So now we can say we created only one virtual machine. Okay, Now this is a Windows system. Okay, this is a Windows system. This is a Linux system. Okay, it will work on different functionalities and all. Right. Now, though it's a separate machine, but it is using your hardware, and it is available on top of your original hardware. Okay, so how we can start this machine, or how we can interact this machine? How we can start? How we can interact in the sense? So in between, you need an interface. Okay, you require an interface. Yeah, I'll make it like this. Okay, you need an interface software on top of your original machine. Okay, yeah, original machine. Okay, through this you can open this machine and you can access it. Now you understand, am I right? So this is your original hardware. Your virtual machine is available there, but you need an interface. Some mediator is required. Okay, to interact, open this virtual machine and to open and work. Okay, this is a mediator software. Okay, this mediator softwares are actually VMware. Okay, one of the famous this virtual machine interface software is VMware.
VMware and Oracle virtual machine, all those.
One of the famous is VMware and Oracle VirtualBox. Oracle VirtualBox. Many other tools are there, but these two are actually it's the popular one under Oracle VirtualBox. Okay, right. So actually here we are using Oracle VirtualBox. Okay, this mediator software we are going to use a Oracle VirtualBox. So what you have to do? First step, you have to install the Oracle VirtualBox in your machine. Okay, how to install and all? You look at this number 1 file. Okay, open this. It is providing all those information. Okay, because I didn't why I didn't download the software in the sense, maybe monthly once they are upgrading it, small patches. Okay, monthly once, 2 months once they are upgrading this very frequently, and this version also yearly thrice or 3 to 5 times they are upgrading this version also. This one also they are keep on upgrading it. That's why I didn't provide the exact software link. I just provided the virtualbox.org. Just go here, whatever the latest software, Oracle software is there, you download it, and to install, okay, the installation with the screenshot is available. Okay, how to install? Screenshot is available. Okay, the first step, you install this VirtualBox. Okay, right. Once the VirtualBox is
available.
Pardon?
It says 6.1, VirtualBox 6.1.
Yes, latest is 6.1. Okay, right. Now after installing, see here the Oracle VirtualBox is available. You open this VirtualBox. See, already virtual machine I imported. That's why it is readily available. If it is not there, actually here a blank section will be there. A blank will be there. Okay, fine. Now you have downloaded this OVA file, am I right? This OVA file is a already virtual machine readily created. Okay, using this Oracle VirtualBox, actually you can create a virtual machine from the scratch. Okay, first you create a new machine, you download Ubuntu, install it on top of Ubuntu, whatever the software you want to install, Hadoop, Hive, everything if you want to install, other thing. Okay, that's the way actually I have created this VirtualBox. Okay, but after creating everything, I created one bundle. Okay, everything is ready. Okay, maybe earlier when you are buying a laptop or desktop, particularly the desktop or laptop, it will come up with empty only. After buying a laptop, then only we will install OS. Okay, with the help of somebody, or if we have the CDs or something, we install software one by one. Then only we will be using it. But nowadays, how it is available, everything is readily available. You purchase.
I have one question.
Yeah.
If you said Cloudera and some third party there,
yeah,
does they give like this whatever you say?
Same OVA only they will be providing. Same kind of OVA only.
Okay.
Cloudera, Hortonworks also they are providing OVA, and some different formats are there. OVA is the commonly used format. Okay, so there actually in that particular format everything is readily available. Ubuntu, everything is installed. Okay. So yeah, comparing nowadays, if you buy a new laptop, okay, everything is readily installed. Windows is installed. Just by the laptop, switch on, you can work straight away. Like, you know, Windows is installed. If you go with in the particular option, OS is installed, Office system installed, and basic some softwares are installed. By it, straight away switch on, we can work straight away. The same way only this particular virtual basin. Okay, I have created everything. I made it a bundle. So inside this bundle, Ubuntu is installed. On top of Ubuntu, different software like a Hadoop, Spark, and Anaconda have installed. R is installed. Okay, this is actually completely a data science machine. Okay, it's a complete data science machine. So if you use this, you can straight away practice all your data science practice, as well as this Hadoop and Spark programs and all. You can straight away use it. Okay, right. So as this already is available, what you have to do, you have to import it. Okay, if you want to create only, you have to just clicking the new machine. You provide the machine name, which OS you are going to install. Okay, if you just specify Linux, see here after Linux, see how many Linux flavors are there. See here. Last time I have mentioned a few only. I mentioned Ubuntu, Red Hat, and CentOS. I mentioned, see here how many. There are so many flavors are there in Linux because of its open source. So many flavors are there. You just mentioned, you can install. If you want to create a new virtual machine, then only you create a new. Here you are not going to create a new. Okay, you are going to use the machine which is readily available. To use this, you go to this second machine, second file. There actually install virtual machine. Okay, the step-by-step instructions are mentioned here. What you have to do, go to VirtualBox, file, okay, and import appliance, and go to the location, click, open, that's it. Then next, okay, all the instructions are mentioned. Okay, so all the informations will be there. You just go and import. If you click the import, it will take some 10 to 15 minutes. Okay, 10 minutes, at least around 10 minutes it will take to import to set it up, because it's a 7 GB memory. To set it up, it will take some time. So you wait patiently, okay, and import it. And after importing, this is actually providing the import instruction, how to importing the instruction and other thing.
All these things are similar to VM virtual machine, right?
Yes. Okay. Now you importing. Okay. And one more advice for you people. Okay. If you have core minimum i3, okay, and with 4 GB RAM. For minimum, I'm talking about the minimum 4 GB RAM. Okay, then only you import this. If you are having 2 GB RAM, it won't import. Okay, if you have 2 GB RAM, it won't import. Right, that is the error actually. Here, this is the minimum. Though it's a 4 GB RAM, I'm providing the warning. Right, even with the 4 GB, it will work very slow. Okay, sometimes in your local machine, you are already running a movie, or some other processor running, not enough RAM is there. Okay, it won't open it, or else even it open, it will work very slow. Okay, ideal is core i3 and 8 GB RAM. If you have 8 GB RAM, it will work, okay, nominally. Nominally, in the sense, yeah, it will work. Okay, why? In the sense, the core i3 will be having only 2 cores. Okay, so 1 core your Windows machine will be using, and 1 core, the virtual machine will try to use 1 core. If we are having 4 GB RAM, what will happen? The 2 GB will be your local machine, 2 GB will be the virtual machine. The 2 GB is not enough. Okay, both way to switch into work and all. If you are having 8 GB, what we can do? Okay, it's like at least 4 GB, 1 core 4 GB, 1 core 4 GB. That is actually good. We can work on it. That's the second file last I mentioned here. Okay, after importing, just go to settings, okay, and system. Okay, in the motherboard memory, you have to mention if you are having 2 GB, 4 GB RAM, it will specify only 4 GB RAM. Okay, you specify 2 is the maximum you can specify. 2 is the maximum. In case if you are having 8, by default it will come for 2 GB only, because I set up as a 2 GB only. Okay, but you increase to 4 GB. In case you are feeling virtual machine is very slow, just go to the settings, okay, and look at here, you are using. So here my laptop I'm having 32 GB RAM. Okay, so 32 GB RAM, so that I have given 16 GB for this virtual particular machine. And look at the processor. Okay, mine is i7. Okay, i7 in the sense actually 6 cores are there. 6 core in the sense actually 12 CPUs. Mine is a 6 core machine. Okay, so each core will be having 2 CPUs. So it is mentioning as in the other way. Instead of 6 core, it is saying it's like a 12 CPUs and all. So I have provided 3 cores to virtual machine, 3 cores to the local machine. Okay, so mine is actually, even I'm working on a virtual machine, that also will work in a very fast manner. Okay, right. So first thing before starting that, yeah, as mentioned in the last slide, last page of this second file. Okay, go to the, just click the virtual machine, go to the setting, and system, in the motherboard, you just check the RAM. Okay, you allot the proper RAM and also processor. Okay, if it is if you are having i3, don't bother this. By default, you cannot change it. Okay, here in case, see, if I want to reduce also, I can reduce it. Okay, now see, only 2 cores for virtual machine, other 4 cores for my local machine. I can change it. Okay, this part. So if you are, but you will be having the option only if you are using i3 and i7. Okay, if you are using i3, the processor part you cannot change it. Just go to the motherboard and the RAM, you can change it. Okay, that's it. After that, you click it, go and start. Okay, now with this interface software, okay, with this mediator software, okay, we are launching it. While launching it, it will take some time based on your memory. Okay, be patient.
The intermediate tool is
Oracle VirtualBox.
okay, and it is like a multitasking, or else
Yeah, multitasking in the sense.
it is operating the OS normal Windows as well as this OVA, right?
No. Yeah. See, from here, okay, with this interface, you start the machine. Okay, once, see here, now the virtual machine is started. Okay, now in my laptop, there are 2 machines are running. One is actual Windows, and this is the this virtual machine, this data science machine.
Okay, understand.
Okay.
So it is like a parallel operating, parallel tasking.
Yes. Yeah. Because I have enough resources. Okay, I have enough resources. So what will happen? If I am running some Spark job in the virtual machine, okay, just I will minimize it. Okay, I will work on Windows. That will be working on parallelly. It won't affect actually. Right. See, the username is LearnBay. Password also LearnBay. Username, password, both are LearnBay. And once you imported, I have provided administrative access to you people. Okay, so that you are having the administrative access, and you have rights to install additional software. It is not mandatory that whatever you installed you have to use it. You can additionally install any software, or else you can, if you want to remove some software, if you want to upgrade, okay, whatever it is, you can use it. You have administrative rights. Okay, this particular virtual machine. Okay, this is the virtual machine. This is the Ubuntu desktop. Okay, see, for training purpose only, I'm going with GUI based Ubuntu. But in practical, if you go with any Linux flavor in practical company, you won't get this kind of Linux based flavor and all. You will be getting like our command prompt, Windows command prompt, this terminal. If you just click the terminal from here, okay, it will like.
This is of which version is this Ubuntu?
Ubuntu 16. So
16. Latest is 20, right?
Yeah, recently 20. Actually, 16 is ideal as of now. We can use it. Okay, 18 also some bugs are there, but we can use it. Yeah, 18.
16 is stable version.
Yeah, 16 is a stable one. That's why I installed stable one. Okay, so this is the Ubuntu machine. Okay, whatever I here mentioned, first I installed the mediator software Oracle VirtualBox. Next, import this one. Okay, that's it. And how to use this virtual machine? Okay, go to your tool. Just click the third file. Okay, it is mentioned one is in the virtual machine help. There are two documents in the virtual machine desktop. Okay, one is list of important application and instruction to use that application. Second is start and stop the Hadoop services. That means daemons. Okay, go to your desktop. There are two files are there. Okay, virtual machine application list. You can see, so these many applications are actually installed. RStudio is there. Okay, how to application this. So click on the RStudio and the application doc. Yeah, here application doc. Okay, it will be Anaconda. Yeah, Anaconda is here. Okay, and if you want to open Jupyter Notebook. Okay, so how to open Jupyter Notebook? How to use Spider? Okay, how to start Hadoop commands? How to start Spark? How to use the Spark? Even MySQL is installed. Okay, how to use the MySQL? For the MySQL, it is mentioned what is the username, and the username is root, and the password is root at 123 as a capital. R is a capital. This is the username and password. Okay, all the instructions are available here. So what are all the? So this machine is not for only the Spark and all. Okay, I suggest you people, if you can install this virtual machine. Okay, you try to build and work like a data science models in this virtual machine, because in real environment there is a high chance that you will get a Windows machine to build the model. Mostly you are forced to work on a Linux based system only. In Linux based system it will be installed. Okay, there only actually you have to build, you have to write everything on the Linux based system only. If you practice here, you will get on some kind of practice that okay, how the real world will be there. Okay. Right. Actually, next, yeah.
So in the real-time industry, we'll use this Linux operating system only.
Yes, Linux.
They will
provide you. Actually, they will provide you Windows desktop. Okay, in that Windows desktop, nothing will be there. Okay, but your projects will be connected to some other server that will be a Linux. From your machine, you have to from my local desktop, I connected this virtual machine. The same way, using some different tools and all, you have to connect it to that particular environment. There only you have to work.
So everything will be work on terminals only.
Pardon, terminals? Yeah. Using terminal, and you can launch actually the Anaconda and everything. There are commands are there. Okay, using some command, you can launch Anaconda. You can launch Spider. Okay, you can open the browser. But the first page it will be when you are connecting to the virtual machine. First page it will come like the Linux system will come like this only, not like this. It will come like this, and from there some commands are there. With that command, if you type, your browser will open, your Anaconda will open, your Spider will open, or any other interface, whichever the interface you are using. There you can write the code as usual. But you should understand that basic commands are. They will provide the training actually when you are getting into the project. The first few days, the environment and how to use all those instructions they will provide. You will get a training.
Okay, even that commands are those included in this virtual machine, or else that is separated?
See, in the virtual machine itself, it is available.
No. After opening the terminal, how to open the other access files, other things by using the terminal?
Using the terminal here, I haven't given. Here I haven't, because we are already using a guide based. So already we are having the icon straight away, browser, Anaconda, everything. Just click, it will open it.
That's okay. Here it is GUI, right? Whereas in terminal we use commands. So we require commands. So the commands are included in this.
No. Here it is not in.
Okay.
Yeah. Fine. Yeah, so after that, now today it's about 10. I will extend this session for another 10 minutes. Just I will show you how to start the Hadoop. Okay, how to start the Hadoop and all. See here, another file you are having virtual machine start stop Hadoop commands. Okay, here we are having the start stop Hadoop commands. Okay, by default, if see here, this is the terminal. Okay, hereafter mostly you have to use terminal only. Using the, if you want to work on Hadoop, using the terminal only. So we have to check, work, most of the things we have to do with the terminal only. Okay, right. Now, if you want to do what are all the services are, I mean, like in Linux, we have to say daemons. What are all the daemons are running? Just type JPS. Okay, JPS command. See here, it is saying only JPS, no other daemons are running. 1 minute, I'll make it.
And Dana, so can you please let us know, so how to copy the files from localhost to the virtual machine?
Yeah, that actually already available. There is a shared folders are there. Okay, you can copy. Okay, you copy from the outside and you can paste here.
Okay, so even I tried before this method, but it didn't work. So I am asking this time.
So, because today, tomorrow I'll show you the instruction. Okay.
Okay then. Yeah, thank you.
Tomorrow how to I'll show you.
Okay. Yeah, thank you.
Fine. See here, the JPS actually we are having nothing. No services are running. No daemons are running. Okay. So to work on Hadoop, what are all the services actually we require? What are all the daemons? For HDFS, we need name node and data node. Okay. These two, if these two runs, then only we can use the HDFS. Okay. To start these two services, go to the virtual machine. In this text file, you look at here to open start stop Hadoop cluster. Okay. Use the below commands. Okay. Open the terminal. Use the below commands one by one. Now start dfs.sh. Okay. Think what we will do, start -dfs.sh. If we do this, first it will start the name node and data node and also a secondary name node. Secondary name node is actually backup node. Am I right? We said the Hadoop 1 version they are said the secondary name node. No need to bother about the secondary name node because when you install configure the Hadoop, by default it will come. Okay. See here, after starting this DFS, distributed file system. Okay. This as per here, the name node and data node. The name node and data node is started. Now you type the command JPS. Look at here. Okay. Data node, name node is there. Secondary name node by default it will come. We are not going to use the secondary name node. Just leave it. As we typed this command, so JPS also will just just come. Otherwise it won't come. So data node, name node is running. Now our DFS system is running. That's it. Our DFS system is running. Next, in case if you want to process some data, what we require? If you want to process some data, I mean, we need to start the yarn, resource manager and node manager. Okay, these two actually called as a yarn, right? Right. So what you do, as per the instruction, go here. The second step is start yarn.sh.
Which shell command is this? Bash shell like?
That's like Hadoop shell command. Hadoop. It is coming from Hadoop only. Okay. Okay. See here, after yarn, starting the resource manager and the node manager. Am I right? This resource manager and the node manager. Okay. One thing is there, if in a real environment, master machine will be separate. Okay. Slaves, multiple slave machines will be and separate. So that in master machine, it's like a name node and resource manager only will be running and master. All the slaves, data node and node managers will be running. But here we are it's not a cluster mode. Okay, it is a kind of a pseudo mode. Okay, pseudo mode. Okay, pseudo mode in the sense, all the services are running on the same machine. In this particular single machine will be working as a master as well as slave. Okay, the same machine is working as a both. Okay, that's a pseudo mode. Okay, and there are three modes are there. Okay, standalone, pseudo mode, and distributed. distributed. This is the practical environment. Okay, this is particularly for learning purpose, training purpose. Okay, or even if you go to the Cloudera or Hortonwork, you will get a virtual machine. There everything is installed. Here I installed very little software, but if you download Cloudera, that will come around 5 GB, I think so. You can go to the Cloudera site, you can install it, download it. Okay, there 20 to 25 tools already installed on. Okay, that also is pseudo mode only. That means a single machine will work as a master as well as server. The standalone in the sense, so even here in the single machine, see here multiple services are running. Now type the JPS. See, for HDFS part, data node and name node is running. For resourcing part, resource manager, node manager is running. Okay, all the daemons are running different as a different thread number. I mean, like a different number, right? Different thread number, it is running different services. But if it is a standalone mode, in this standalone mode, all the services will be running on the same thread only. Okay, the node manager, everything will be on the same number only. Okay, that when we want to test something, very rarely only we'll be using. If somebody say that I'm using standalone in the sense, okay, he is like very beginner stage, or else he is testing something very small thing, that is a standalone. Okay, mostly for training purpose, for learning and other thing, we'll be using pseudo mode only. Distributed is actually practical environment. Master is separate, slaves are separate. This is the thing. Okay, now it's a standalone. See here, that's it. All the services are running. Now in this machine, okay, in the background, Hadoop services are running. Okay.
Can you explain again pseudo mode, please?
Yeah, pseudo mode in the sense, say this is the practical mode. This is the distributed mode. See, the master node is separate. Okay, and all slaves are separate. Okay. See, in the master node, only name node and resource manager only will run. But every slave node, data node and node manager. In the slave node, name node won't run. In the name node, data node won't run. Okay, this is actually practical. But in a pseudo mode, everything on the same machine only. This is our machine.
So we are creating like a virtually like a distributed systems in the pseudo mode, right?
No, not it's a distributed system. In the same machine only.
Like a replica of distributed systems.
No, see, in the distributed way, this machine will be having different IP address. Okay, this machine having different IP. They having different IP. Okay, based on the IP address only, we are making the connection. Okay, we will be having. But here, all the services will be sharing the same IP address. Okay, it will be running on the Java virtual machine. Okay, every services is running on a Java virtual machine. Okay, just the same machine will work as a master as well as same as a server. Comparing with the small company, one manager will be there. Okay, he will be managing the project. He will be managing the HR. He will be managing the interview and everything. He will be doing everything. Am I right? That is like the standalone mode. The pseudo mode. In the pseudo mode, all the services are running on the same machine. The same machine will be working as a master as well as a slave. What this will do in this particular machine? Okay, some part of the RAM. Okay, the name node will share and it will keep the metadata on it. Okay, metadata on it, and also in other core it will the data node. Okay, using the other core. Okay, if you are running some program and all, okay, it will be working. Fine.
Okay, it is similar to the real scenario, but it is sharing the same IP.
Same IP. That's it.
Okay, and whatever the other numbers are there just before the demos, all those are PIDs, right?
Yeah, this is PIDs, process IDs. Yeah.
Okay.
Okay, this is the PIDs. Okay, right. Okay, so before closing the session, okay, just with one simple command, HDFS command, and I'll wind up today. And tomorrow we'll start with Scala. Okay, right. See, after this, so now we are into Linux. Okay, in the Linux command, okay, if you want to see in which in which folder we are there, we have to use pwd. Okay, pwd. That's the parent work directory. Okay, I mean like sorry, not sure. Working directory. This is working directory. This is parent, or it's like a processing or something. I'm not sure. Okay, PWD. Okay, in command prompt, Windows command prompt, we use dir command, dir. Okay, here actually PWD. And also, if you want to see the now what are the files are here, okay, ls, type the ls. In Windows, if there is we are into one directory, I am into this directory. If you want to see what are the files, just we'll click it, we can see, oh, these many files are there, just straight away. Okay, and print working directory. Thank you. Okay, this one. And even here also we are using this guy oriented Ubuntu. Just to see here, this is our file system. Just if you open some folder, just click it, we can see what are all the folders are there inside, we can view it. But if you are forced to use only on the terminal, okay, there is no my computer, or there is no guy oriented. If you are forced to work only on this command from the terminal, if you want to see what all the files are there, okay, we have to use ls. Okay, so ls is listing the files there are in the Linux system. There are in this operating system. Okay, in case if you want to see Hadoop, okay, because Hadoop is installed on this Linux system only, but it is available on in separate place. Okay, it's like a virtual. It is on separate place virtually. Okay, if you want to see what are all the folders files are there, this is the basic command Hadoop file system, Hadoop fs. Okay, and mostly it will be like a Linux command only. Mostly like Linux command only. To list, actually we are using list, but whenever you are using a Hadoop file system, you use -ls. Okay, then you specify the namespace, only the root directory. Okay, we specified because we already I said in Linux system there is no directory structure, C drive or D drive. Okay, straight away the namespace is having straight away one root. I mean, if after this is the root folder or root directory, from root directory you create any number of sub folders and subfolders files, you can do it. Okay, you just run it, it will take some time. Okay, see here, there are in the Hadoop, there are some 4 top level folders are there: temp, test, tmp, user. Okay, these many folders are there. Okay, this way we have to access the Hadoop. Okay, it's like a Hadoop fs -ls. Okay, under user. Under user, if you want to see what are all the folders are there, see under user. Okay, some subfolders are there. LearnBay one subfolder and one Spark folder. Okay, this is the basic Hadoop commands. Okay, so I have provided the 4th file. What are all the basic Hadoop commands are there? Okay, you just practice it. Anyway, tomorrow I'll once again I'll show you this basic Hadoop commands, and we straight away switch into Scala language and Spark introduction tomorrow. Okay. See, if I type ls, it is listing immediately the Windows system. But if I go for Hadoop system, see, it is taking some time, because when you are asking this request, your request is going to the name node. Okay, and the name node is looking into its metadata. What are all the what is the request? Okay, under root directory, what are all the folders where it is there? Then the name node talking to the data node, and it is providing the sub directories. Okay, that's why it is taking some time.
Now it is under SU only.
Pardon?
Now it is under SU only.
SU, I could get you.
Super user only.
Yeah. Sudo user only. Yes.
Okay.
Yeah. I said, your machine is actually, this machine is having full administrative rights. It's not a restricted.
So having all the privileges.
Yes. Even if you go SU, the password is root.
Okay.
If root is not working, the password, the SU password will be LearnBay only. If it is asking password, okay, you go for LearnBay. Username is LearnBay, password is LearnBay, root password is LearnBay, Only for if you are going for MySQL, that only different password, that too mentioned here, mentioned it, that file, that file. Okay. Fine.
Okay, thank you.
Okay. Now I think, whatever the couple of days, whatever we have seen here, the virtually, I mean, imaginarily name node daemons, data node daemons. Okay, so many daemons we are talking. Now we are physically seeing that how the services are running, how it is working. Yeah. Okay, so I'm winding up here today with this, and